Next, we're going to move on to the next layer in our OSI layered model stack, which is your network layer, or layer 3. The network layer controls communication between broadcast domains. So if you want to go from one broadcast domain to another broadcast domain, you need layer 3. Specifically, the device that works at the network layer, you need a router. So, to draw out an example, let's say you have a switch here with 2 hosts or 2 PCs sitting on it, and you know that a switch is one broadcast domain by default. So let's say we only have VLAN 1 here. So this is in VLAN 1, and this is VLAN 1. And then you have another switch, and this is in this PC 3 is in VLAN 50, for example, and PC 4 is also in VLAN 50. So if you want PC 1, which is in VLAN 1, to communicate with PC 3, which is in VLAN 50, you need to use layer 3, or more specifically, you need a router. You cannot connect these 2 switches back to back with each other, because PC 1's just simply not going to talk to PC 3, because those are 2 separate broadcast domains. Now, granted, VLANs are layer 2 broadcast domains, and in a little bit we're going to cover layer 3 broadcast domains, but the concept remains the same. To go from one broadcast domain, in this case VLAN 1, to another broadcast domain, which is in this case VLAN 50, you need the process of routing, which is a layer 3 function. And the device that provides the process of routing is called a router. So the device that works at layer 3 is a router, and the function of layer 3 is to send data between broadcast domains. Now, the protocol data unit at layer 2 was called a frame. The protocol data unit at layer 3 is called a packet. Before I draw the packet structure on the board, just like at layer 2, you needed some sort of addressing scheme. So just like at layer 2, you needed some sort of addressing scheme to send frames between devices. So you needed a source MAC address and a destination MAC address. So the addressing scheme at layer 2 was MAC addresses. At layer 3, the addresses that are used are called IP addresses. So let's begin with IP addresses. An IP address is 32 bits in length, and it's written in 4 fields of 8 bits each, separated by a dot. This is called the dotted decimal format. So 4 fields of 8 bits each. Let's find out what it looks like. So x dot x dot x dot x equals 32 bits. Now x is a number. X is a variable. I put x instead of putting a number. We'll discuss what goes in the place of x in a second. Now, each one of these fields is 8 bits. So 8 plus 8 plus 8 plus 8, 8 times 4 equals 32. So let's take this first field and expand it out into its constituent bits. 1, 2, 3, 4, 5, 6, 7, 8. So I'm basically taking this first field, also known as an octet. Not really hard to think about how they came by that. 8 bits, octet, octopus. And once again, we're going to number these bits with specific values. So you start at 1, you double it, you go to 2, you double it, 4, double it, 8, 16, 32, 64, and 128. So 1, 2, 4, 8, 16, 32, 64, 128. Once again, I'm drawing out this first octet or this first field. If I turn all these bits off and I put zeros on top, then I get a value totaling 0. However, if I turn all these bits on, which is a value 1, then I need to add all these numbers up to get what value I would yield. So 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, plus 1 is 255. Each one of these values, each one of these fields, or octets, can vary or range between 0 and 255. The maximum value being 255, the minimum value being 0. So an IP address would look something like so. 10.0.128.50. Depending on which bits are turned on and which bits are turned off within each successive field or each successive octet. So for example, over here, only the 128-bit value is turned on and the rest of them are off. On the first octet, the 8-bit value and the 2-bit value are turned on, and the rest of them are turned off because 8 plus 2 is 10. So back in the day, when the internet was young and IP addressing was brand new, IP addressing was broken down into classes called classful IP addressing. And there are certain rules that must be followed with classful IP addressing. Nowadays, IP addresses are not broken down classfully. They are broken down classlessly. However, to understand classless IP addressing, you must have somewhat of a grasp or a firm grasp of classful IP addressing, where IP addresses are broken down into classes. So the first class we have is Class A. For Class A addresses, the next field I'm supposed to fill out is the value of the first octet. So for example, in the x.x.x.x example, this is your first octet. This is your second octet, this is your third octet, and this is your fourth octet. So I'm only going to put the value of the first octet. For Class A addresses, the value of the first octet has to be a number between 1 and 126. It has to be. If it's not, then it's not a Class A address. So in this case, this number has to be a number between 1 and 126. Now there's something called a subnet mask. I'm going to explain what a subnet mask is in a little bit. Right now, just take it for face value. The subnet mask for a Class A address has to be 255.0.0.0. So the first octet, as you saw, is all ones. It's all full. The third, fourth, and fifth octet are set to 0. Now, what is this CIDR notation or classless interdomain routing notation? This is basically a way for us to be a little lazy. Instead of writing 255.0.0.0, if I were to ask you how many bits in the subnet mask are on at this point, there are 8 bits on. Since all the bits in the first octet, which is 8 bits, are on, you get the value 255. So I can simply denote this whole thing as /8, 8 being the number of bits that are on in the subnet mask. As an example for a Class A address, I can say 10.10.10.10/8, which would be the same as saying 10.10.10.10 255.0.0.0. The next class we have is Class B. For Class B, the value of the first octet must be a number between 128 and 191. I haven't forgotten the number 127. I'll get to it in a minute. So for Class B, the value of the first octet has to be a number between 128 and 191. The subnet mask is 255.255.0.0. So now, what would the classless interdomain routing notation be, or the CIDR notation be? The first octet is all ones, which is 8 bits. The second octet is also all ones, which is another 8 bits. So 8 plus 8 is 16. The third and fourth octet are off. You get /16. An example of a class B address would be 150.101.45.45/16. Next, you have class C. For class C, the value of the first octet, again, keep in mind, this is just the value of the first number, the first field, or the first octet. So the value of the first octet has to be a number between 192 and 223. And the subnet mask is 255.255.255.0. What would the CIDR notation be? Well, the first octet is all on, which is 8 bits. So is the second octet, which is again 8 bits. So is the third octet, which is again 8 bits. 8 times 3 is 24. 24 total on bits in the subnet mask. So I can say /24. As an example, I can say 200.0.0.30/24. Then there's also a class D. Class D addresses range between 224 and 239. Class D addresses do not have a subnet mask, and they are used in multicasting. Now, we all know what a unicast is. A unicast is one-to-one transmission. We know what a broadcast is. It's like junk mail, one-to-everybody transmission. You're going to get it whether you want to or not. A multicast is like a magazine subscription. It is a one-to-many transmission, but the hosts have to be subscribed to the feed. So, a multicast is a magazine subscription. Like, unless you subscribe to it, you're not going to receive it. A broadcast is like junk mail. You're going to receive it whether you want to or not. Then there is the class E. I believe it goes from 240 all the way to 255. And this is experimental. So experimental and unused. You notice that I left the number 127 out. The 127 is not in this range. The whole range, 127.0.0.0, is reserved for testing. The 127.0.0.1 address is called the local loopback. If you can ping is a testing utility. If you can reach this address, okay, or if you can ping this address. Now we'll go into more detail what ping is and what protocol it uses later on. But if you can, for now, if you can reach this address or test for this address using a command, a utility called ping, then that means that the TCP/IP protocol stack was properly installed on your machine. If you cannot ping this address, take your PC back to Best Buy.